All right, so I think I'm recording. Here we have a 3x3 system of equations. First thing we need to do is make sure it's lined up or written right. The x's are here in this first column, the y's in the next column, the z's and all the constants on the right hand side, so it's set up nicely. We're going to solve this by the method called elimination. When I scan this, I'm going to look for numbers that are equal and opposite or ones, and like x's appeal to me, but even excuse me, more than the x's, I would eliminate the z. So that's the first decision that I need to make, and then I need to stay consistent with that decision. So I'm going to eliminate the z variables, and I'm going to turn this 3x3 system into a 2x2 system that has two equations and just x and y. So I'm going to just start off right away adding equations 2 and 3. If I number these 1, 2, and 3, I'm going to add these two equations together. So I've got equation 2 and equation 3. Put a 1 there just for visual aid. I can see that the coefficient in front of z is equal and opposite. That's why I chose these, because now when I add these together, the z is going to cancel. Here I have 3x's. Here I have 7y's. The z's cancel. Negative 10 plus a positive 5 is negative 5. I'm going to call this equation 4. So now I need to have a second equation that's just an x and y. Let's see, which equations did I use here? I used equations 2 and 3. So this time I have to use equation 1, either equation 1 in combination with equation 2 or equation 1 in combination with 3. I'm going to use 1 and 2 because the coefficients are opposites, but I need this 1z to actually be a negative 2z. So I'm going to multiply everybody that's in equation 1 by 2, and I get 2x minus 4y plus 2z is equal to 24. And then equation 2 I'm just going to leave as is. And I can see that the z's will end up canceling because the numbers are equal and opposite. These two x's and another 2x adds up to 4x minus 1y. The z's cancel, which is we wanted to happen. We've got 14. I'm going to call this 5. So now I look at equations 4 and 5, and I need to either eliminate x or eliminate y. Well, I've got a 1 here and a 7 here, and actually it's a negative 1. If I multiply equation 5 by 7, I'll have a positive 7y and a negative 7y, and those will easily cancel. So that's my next plan of attack, is to eliminate y. I'm going to leave equation 4 as it is. 3x plus 7y is equal to negative 5. But here in this equation 5, I need that negative 1y to be a negative 7y. I'm going to multiply everybody by 7. So 7 times 4 is 28. Then my minus 7y. And 7 times 14, I think, is 98. Let's check that. Is 7 times 14, 98. And it is. So let's add these two equations together. Oh, I forgot my x here. 7 times, I forgot the x. 3x's and 28x is 31x. The y's cancel. 98 minus 5 is 93. Is that divisible? Let's take 93 and divide it by 31. See what we get. Alright, we've got to make sure that we use the calculator efficiently. Divided by 31. Hey, we get 3, which is, which is what I knew we would get. Alright, so I'm part way to my solution. I'm a third of the way, because since I had 3 variables, they want x, y, and z. So I just figured out what x is. So I can come back and use equation 4 or equation 5 to figure out what y is. Since that's just a minus 1y, I'm going to use equation 5. So everywhere I see an x in equation 5, I'm going to replace it with 3. So now I can solve this equation for y. 4 times 3 is 12. I'm going to subtract 12 from each side. Don't lose that negative sign in front of the y. 14 minus 12 is 2. The opposite of y is equal to positive 2. Multiply both sides by a negative 1, and y is equal to negative 2. So now I have 2 of the 3. I need to know what z is. I need to return back to the original equations and pick either equation 1, equation 2, or equation 3. Since I'm solving for z and that's just a 1z, I'm going to pick equation 1. I know what x is, however. I know that x is 3, so right here, for that x, I'm going to replace it with 3. For that y right there, I'm going to replace that with negative 2. And I'm trying to solve for z. So I've got negative 2, negative 2. I've got 3 plus 4. I've got 7. And we know that if I subtract 7 from each side, that 12 minus 7 is 5. So I believe that I have my answer. The xyz is equal to 3 comma negative 2 comma positive 5. If I had time, I could plug it in and check and see if each of these equations satisfies. I got to be careful just checking one, but we can do that really quickly. If we check this equation 1 is 3 minus 2 times the negative 2 plus 5, is that equal to 12? So we've got 3 plus 4 is 7, and 7 plus 5 is 12. So it definitely checks on the first equation. I'm willing to bet it'll check on the others. On a test, I may not have time to check all 3, but I'm pretty confident that that's our correct answer. So hope that helps, and I'll talk to you later.